We proceed with example number 8. We are now given the thermochemical equation for aluminum oxide, decomposition of aluminum oxide to its elements aluminum and oxygen. And we can see that the enthalpy change of the reaction, standard enthalpy change of the reaction or the decomposition of aluminum oxide is 3,351.4 kilojoules, meaning mo absorb siya og heat para mo decompose aning iyahang elements. So we are to calculate the heat of formation of aluminum oxide based on this. And we are to calculate the standard enthalpy change for the formation, this time of 12.5 grams of aluminum oxide. So how are we to solve? So letter A, I think it's very easy. For letter A, diba? Enthalpy change, standard enthalpy of a change of a reaction is products minus reactants. And for the products, we have upat ka aluminum na solid plus tulo ka oxygen nga gas. And for the reactants, we have duha ka aluminum oxide na solid. And this is equal to 3,351.4 kilojoules. And because these aluminum and oxygen here are free elements, so automatic nga zero ang iyahang zero ang ilahang standard enthalpies of formation. So we can just cancel them out. This is 0, this is 0. So what is left is kanina lang. So ang pasabot na to ani that's kulang og L. Ang pasabot na to ani is the enthalpy of formation, standard enthalpy of formation. So pwede na nato we can transpose this here and also 3,351.4 padung sa pikas nga side. So this will become positive 2, and para klaro na to, 2 delta H degrees of formation of Al2O3. No? That's equal to, butangan na to, solid, equals negative 3,351.4 kilojoules. But since there is still a coefficient here 2, so we are to divide the entire equation by 2. So the standard enthalpy of formation of aluminum oxide nga solid is negative 3,351.4 kilojoules divided by 2. And that is equal to negative 1,675.7 kilojoules. So this is our answer for letter A. Now for letter B, we are to calculate the standard enthalpy change for the formation of 12.5 grams of aluminum oxide. Formation. So ang given diri nga equation kay, so man ni siya, this is decomposition. Ang atong gipangita diri kay ang ni siya, formation. So baliktaron na to, class. So for letter B, reverse the given equation. No, we can reverse the given equation. So if ang given nga equation kay 2Al2, let me write it again, that's solid. Mo decompose siya into its elements plus 3O2 nga gas. So heat is absorbed, 3,351.4 kilojoules of heat is absorbed. And when we reverse that, so mo-form siya from its elements, so 4 aluminum plus 3O2, that's 2Al2O3 nga solid. And so the standard enthalpy of formation is, so man siya, kinahanglan siya mo release og 3,351.4 kilojoules of heat. And this equation is now what we are going to use. So, balik ta sa pangutana, ang iyang question is, calculate the standard enthalpy change. So, pila kuno ang standard enthalpy change of the reaction for the formation of kanisiya, diba? Take note, this is 2 moles. Pero ang given na karon kay 12.5 grams of aluminum oxide. So again, kay moles man ni ang ipakita diri sa thermochemical equation, but this is the mass given here. So just like what we did with all the previous examples, we have to solve for the molar mass of aluminum oxide. So duha ka aluminum plus tulo ka oxygen. Now let's use the whole number for aluminum. That's 27 plus tulo ka oxygen nga 16. And that would give us an answer of 102 grams per mole. And then we can solve for delta H, standard enthalpy of formation of aluminum oxide given 12.5 grams. So delta H with a degree, don't forget the degree symbol kay standard, and we always start with the given 12.5 grams, and take note this is for Al2O3. So using our molar mass as conversion factor, now for every 102 grams, again that's for Al2O3, that's equivalent to 1 mole Al2O3, and we can cancel grams. And from the given thermochemical equation, niingon siya nga asa man napita atong Al2O3 nga relationship. Sa duha kuno ka moles nga aluminum oxide formed from its elements kay mo-release og heat nga 3,351.4 nga kilojoules. So naana ta sa 1, so 2 mole Al2O3 negative 3,351.4 kilojoules. And again, when you compute, you multiply ning duha and divided by. And that would be equal to negative 205.36 kilojoules. So ni siya, this is the standard enthalpy change for the formation of 12.5 grams of aluminum oxide from its elements.